what we did was to go down and determine that the slope of the secant is equal to 0. We're now determining the slope of the function. So let's see, I've got to take 2 times the sine, the derivative of 2 with respect to x of 2 sine x, plus the derivative with respect to x of sine 2x, as I recall. Yep. Do you see any composite functions in that? I'll do the first one. Derivative of 2 sine x is 2 cosine x. You said yes? Yeah, the sine 2x. So help me out, Lindsay. Cosine 2x. Okay. So I've got 2 cosine x plus the derivative of 2x is 2, so that's 2 cosine 2x. I can factor out a 2 just fine. I've got the cosine of a double angle. That may or may not be something that you remember. If you don't remember what the sine of a double angle is, and you have your textbook, you can always look it up in the textbook. If this comes up on a quiz, you're welcome to come up and ask me. Again, on a trig class, I require you to memorize all of that. For this class, I would give that to you if you don't know what it is. So it would be, let's see, 2 cosine x. Anyone happen to know what that is? Okay. It happens to be, and I've got to make sure I get this right, 2 cosine squared x minus 1. I'm sure in trig class you verified those identities and came up with that, but those are the types of things that we can lose quite easily. Okay, so now let's see. I have 2, and inside here I have 2 cosine squared x. I'm rearranging these for a purpose, plus cosine x minus 1. Now, if I'm going to set this equal to 0, I'm going to, let's just say that then, and I'll just put for the sake of the note, set f of x equal to 0. Why do I, or the derivative rather, why do I want to do that? Yeah. Yeah, if I, I'll just do that here. If I look at that, okay, got the arrow came with, but anyway, if I do that, then again, the theorem states, let's go back to the theorem here. The theorem states that the derivative has the same value as the slope of the secant. And so if I know the slope of the secant is 0, then the derivative must also be 0. So I have 0 equals 2 times 2 cosine squared x plus cosine x minus 1. And we're kind of stuck unless we think of one of our algebras. First of all, because the product is equal to 0, it means that either 2 has a 0 value, which is not true, or 2 cosine squared x plus cosine x minus 1 has a value of 0, which is what we're going to have to take. So we would say 0 equals cosine squared x plus cosine x minus 1. But what are you going to do with that? How do you mean factor it out? You're going to take a cosine x out of these two terms? Yeah. Think of it as a polynomial. So the polynomial factoring is more than just for, trinomials. It's a whole process we can use. So if this were, 2a squared plus a minus 1, how would you factor that? probably a 2a and an a. And then you'd have a plus 1 and minus 1. And so let's see, I'm going to have to make this probably a plus 1, so I get my positive and my negative. So 2a minus a would be positive a, which would be equivalent to that. So if we think of it as a polynomial, we would have 2 cosine x minus 1 times cosine x plus 1. Now, whether or not that was immediate to you to think of that depends on, how well you're able to see the polynomial format in something other than just 2a squared plus a minus 1. Now that we've got this, then we can say that 2 cosine x minus 1 is 0, or cosine x plus 1 is equal to 0. Now we can split those factors up. Cosine x equals 1/2. Cosine x equals -1. Okay, then we have to think about, okay, which triangle has a hypotenuse of 2 and a side of 1? Again, it may not be easy to think of this, but you got two choices, a 45-45-90 or a 30-60-90. If you think about the 30-60-90, if this is 1 and I duplicate it, you've seen me do this over and over again, that means this whole side is 2, which means that's 2, and this side is the square root of 3. So if I want the cosine, and the cosine is 1/2, it must be the cosine of 60 degrees. So x would have to be 60 degrees. What is that in radian measure? I divide by 3. Okay. Over here we have cosine x equals -1. For that, I think of the unit circle. Where would I have a cosine as -1? It's going to be at pi. Now, are these the only places where cosine is 1/2? If it's 60 degrees, it could also be down here with a terminal side in this direction. And if that's the case, then what would be the radian measure, or what would be the angle measure? If the terminal side is down here, let's see, 360 minus 300 degrees, what would be the radian measure? 2 pi minus pi divided by 3. What do we have there? 5 pi divided by 3. Okay. So this could be also 5 pi divided by 3. If it's -1 at pi, it could also be -1 at 3 pi. Any rotation, it's going to bring it back. But what do we have to consider here? The interval is only 0 to pi. Okay? Only 0 to pi. So, do we have to be concerned about 5 pi divided by 3? No, it's not in the interval. Okay. It's an open interval, pi divided by 3 to pi. And so we would consider, well, can we consider pi? Would this work? Is it in the open interval? Open interval? What's the open interval mean? It includes it? It doesn't include it, right? It means it does not include pi. It comes as close to pi as you want, but it does not include pi. So can we include this one? No. So this is not in the interval. From 0, the open interval from 0 to pi. So what is our answer? In other words, what? We'll say XC in this case. In other words, what? Now this is where you get to verbalize what this this theorem is saying. When x is equal to pi divided by 3, what's our conclusion? Okay, well, let's do this. You have your inspires. Let's add a graphing page, and let's put in our function. 2 sine of x plus sine of 2x. I don't know. This may not. Doesn't look like it's going to do. Let me see what happens. Well, it did work. Okay. It didn't have it in italics, so I was wondering if it was going to graph. Did you guys get this to graph? Change your window. Why change a window? And we only need it to be for what, Lindsay? 0 to pi. Okay, so choose a window. I'm making mine just a little bit larger. Oh, let's see. So I had negative pi divided by 4 to 5 pi divided by 4. I scaled it by 5, or pi divided by 2. And when I hit enter inadvertently, it went to decimals. And then negative 2 to 2. And I messed up on that, so I'm going to go back and change it now. And make sure that I've got my maximum to be something that will see it. So change that to negative 1. So I have negative 1 to 4 on my output, and that looks a little better. Okay. So I need to now look at a secant between what and what? What's my open interval? 0 to pi. Okay. So I know where that is, but I'm going to go ahead and put a point on. And I'm going to put a point on here and a point on here. And of course, I'm going to change my coordinates and make it input of 0 and input of pi. Okay. And I'm not surprised. I don't even have to do the derivative there. I think I can see that just fine. Now, we're saying that over here, that if we're looking at a point at pi divided by 3, a tangent at that point has the same value, slope value, as our secant. So I'm going to put another point on. This time a point's up here. I'm going to change the coordinates of that to be pi divided by 3.